Hello and welcome to yet another episode of Into Design, where we are taking you through some of our projects. And today we're looking at Henry II. And if you've seen the previous episodes, you know that around about now we've actually ended up at the CAD work. Let me show you the screen here. The lookbook again, sort of our holy grail when it comes to the project, and every single project we make one. Here we see the surfacing, the skin of the car being made in computer-aided design. So how does that work? How do we get there from a sketch, a handmade sketch, digitally, of course, done, but entirely done by hand, a bit like an oil painting without the actual paint. And how do we translate that into this? That's actually quite complex. And it's not just a press of a button, as some people might think. So Tim and myself will take you through that process in this video today.
Yes.
And that starts with actually 3D scanning the original car, the donor car. And based on that, the first surfaces are made, sculpted, if you like, in CAD. This is not, again, just a click of the mouse. You're kind of sculpting digitally what you're designing on paper or on the computer. And that starts, as always, with research. And if I can show you the screen again. In this case, it is a Rolls-Royce Silver Dawn. We've shown you in other videos also silver clouds. Quite a few different heritage cars we used for our research, for our mood boards, for input into design. You see the curvature that we discuss. You see the surfaces, you see the rear window pushed into the bodywork. You see that third box, very typical, and the way it sits on top of the bodywork in a very soft, creamy, yet quite well-defined manner, with this quite angular and square horseshoe shape pushing through the surface there. Quite a delicate piece of car design, and important for us to push through into the design of Henry II. What do we see here? Well, these are, like I said, the first initial 3D scan-based surfaces onto the car, with a lot of feedback that we write for the CAD modelers. Tim can talk a bit more about what you're seeing here, some of the challenges we had with the window planes as well, and other challenges at this stage.
Yeah, because the windows were flat, right?
They are flat, yeah.
So with the tapered in design, extending the windows with the flat surface, we would end up outside of the car.
Yeah.
So we had to bring them inwards from the B-pillar.
Yeah. Ever so slightly, because it's
just a bit,
yeah, it's important to mention here, if I can show you the sketch here again, just to explain what's really going on.
Yeah.
So the conversion is B-pillar backwards. This is a flat piece of glass. Normally, even in the 70s and 80s already, most brands had curved glass. From top view, the car is like a Coke bottle shape, but also from top to bottom. And you'll see any modern car has double curved glazing. This car, however, has not. So this is a flat piece of glass, and then the original Mulliner Parkward Coupe had a window up until there. That was okay, but now we're extending that window almost 3 times of its original length. And exactly what Tim is saying, if we would have done that in the same plane, so in the same surface as the front window, from a top view perspective, it would come out of the car. So the window here, this is the B-pillar, it would come out of the car. So we had to push in that rear corner. We couldn't make curved glazing for this car because it would have been very unpleasant when it comes to the light and shadow interplay. But now you actually cannot see that that rear window is under a slight angle, just to be able to make it to the end of the car with the glass inside of the car.
Yeah. So that's what you're seeing here, right?
Yeah.
So with the small steps and with this, well, pink section view, it's explained how we wanted to have the pushed inwards look.
Yeah. What do we see here on the right hand side image?
A lot of lines,
Yeah.
And with those lines also section views to explain what's going on with the surface and what we want from the surface.
Yeah, so a section is basically taking a knife through a cake, right? From top to bottom and horizontal slices. And you could take that cake apart and look on top of it, or you look on the side view, you know exactly what the outline is of that particular slice of the cake.
Yeah.
And that helps the CAD designers we have, and you do the CAD as well here at Niels van Roij Design, to understand the surfaces and how they're built up.
Yeah.
Right?
So this is the thing we have next to us when we develop the car digitally.
Exactly. Yeah.
So you can see it over here, all the green lines, with some red lines as specific features we want to emphasize. So here also the horseshoe that Niels explained, referring to the Silver Dawn, going like this, which is also obviously visible in the sketch over here. And in the final car over here, going like this. So slightly curved, fading to nothing.
Yeah, and we'll explain in this video how complex it is to do just that. To generate surfaces that look good in real life is a big challenge, and actually every single modern piece of car design, whether it's a Dacia or a Rolls-Royce or anything in between, is solved in such a way. Every single car is complex, every single car has its own challenges, and to get the surfaces right is quite a bit of a job. Yeah,
For sure, yeah.
yeah. Let's move on to the next page in the lookbook here. So this here, top images, are images of the final CAD model. The bottom is the 3D scan. You can see it's not entirely scanned up to the bottom because the top end of the surface there of the door and the rear fender were reused. So everything below that we didn't have to redo. However, on the left bottom corner, we see how these surfaces are actually built up. So, like I said, it's not just a few clicks of the mouse and the whole car is there. No, this is hard work and complex work to resolve. And we start a bit like if you would actually make a clay model, you don't start with the small details. That's not possible. You first go, okay, so where's the roofline? Well, this is the roofline. Okay, and then how do we sculpt the side? Well, roughly here. So this is the main shape of the body. And then we start going deeper and deeper and deeper and deeper. So if you look at this image on the left-hand bottom corner, you'll see the roofline is roughly there. You see the side surface is roughly there. You see one big main surface of where the window sits in, but you can see it's actually running underneath that bootlit third box that we discussed in previous videos. So it's just one big main surface where we say, okay, now we control that surface, that's where it needs to be. Let's now look at that top end, let's say that shelf, that horizontal part of the third box. And then we look at the vertical element of the third box. And you see there's a lot of holes still everywhere. Nothing is connected. These surfaces are floating in midair. And the connection comes a whole lot later. Again, the connections are the tiny little details in the clay model. You can't start with these. You first do the big chunks. Or if you have a big piece of marble and you're making Michelangelo as David, Michelangelo didn't just start with his face. He starts with the rough outlines of the body and then zooms in on the arms and then zooms in on the muscles and then zooms in on the veins, let's say. That's exactly how we work as well. So let's move on to the next image, the next spread of the lookbook. There we see actually the sort of final CAD model of what is going to be made. So this is excluding the tail lights, excluding chrome, excluding the handle that sits on the back, excluding all the other bright work. It's just the main surfaces of the boot and the C-pillar and the roof and the bright work that has to be made, which is the bright work around the window of the back and the window at the side. So that brings us to these images. Tim can talk us through what we're actually seeing here and why that's interesting.
Yeah, so on the left we see the side view, or a slight side view of the final surfaces.
Mm-hmm.
You can recognize the buttress. You can recognize how the third box is not just a box and is an interesting way of surfaces that come together, where we first saw several planes. They are now tied into each other
Yeah.
with certain sharpness or certain roundness.
Yeah, softness, and that's all controlled.
Yeah.
So whatever you see, this is no coincidence. And this goes for every single car. So also horrible cars, they made horrible mistakes. And in this case, we try to not do that. So what you see, every single surface and every single transition from the planes, so from the big main surfaces that Tim described, we have a horizontal, let's say, shelf surface and a vertical upright surface. They come together somewhere, and this surface could be curved, but that surface could also be curved, but it could also be angled, and that's, you see what's happening? And then somewhere they come together in a certain way, but that line is also defined. So if that's a hard cut, like a folded piece of paper, or if it's like a sculpted piece of clay, or anything in between, that's completely controlled, and also the acceleration of that line. So if we're moving back to this image there, you can see this line is more defined on top, and then towards the side it gets softer and softer and softer and softer, up until a point where you can't see it anymore, where you can't see if there's a surface or a surface transition, right? So a transition between two surfaces or just one main surface. And that's the beauty of car design. It's one of the few, I would say one of the few places where surfaces are being treated with so much delicacy and so much knowledge as well. We're now at the actual CAD model, and here you can see how all these surfaces are stitched together. So you see the main surfaces with these big lines, right? These are the main head surfaces. But for instance, here we have this leading edge of the roof, which is like a rain gutter, and you can see it consists of many different subsurfaces, because there's a highlight on top of that. We have to describe that highlight. We have to describe how it comes out of nowhere and then dives into the car, and then there's another main highlight of the crowning of the roof, which is way softer, which is also described. And here they all come together, and we want that highlight to actually fade out to nothing, so it doesn't compete with the main gesture of the surfaces there. And that surface is fading out in that exact area between these two boxes. And that's just one little detail. So Tim will show you a bit more, including the boot area with that horseshoe shape.
Yeah, we can recognize it.
We here see actually the 3D scan coming through. So this is the original, and there it is, the original scan of the shut line of the original Corniche. So this would be the lock, and the boot would end roughly there. So you see how much deeper we've cut out the shut line of our design. And of course, yeah, that's the boot. You see the scan there, and indeed also here you see from a top view what we've done with that original surface and how we've made that hollow rather than straight as it was on the original Corniche.
Yeah, so the dark gray, this is the original surface, and we've chosen for more depth and more shadows, and that way we wanted to create a deeper body, and we ended up trimming all the way till the edge of the tail light.
Yeah.
In such a way that we also redefined this part.
Yeah, generating new ideas, a new character for this specific car was key, but staying within the confined space, if you like, of what Rolls-Royce is and what Rolls-Royce means, what the surfaces have done in all these years, how the transitions work. So this has always been designed in such a way that Muller & Parkward could have designed it. Let's have a quick look at what's next, because this is just a surface model.
Yes.
And what do we do with this?
Yeah, how do we get to a physical car?
Yeah.
So let's first hide this one.
Yeah. So the boot is out now. And this is a so-called buck. And the buck is basically a big amount of wood different slices of wood. You can see the numbers on the back, A, B, C, D, E, etc., and 1, 2, 3, 4, etc. Different colors in this case, just for you to identify the different slices. And this is just for the body, so you can see there's no tailgate shape in here yet. This is just for the body to build up, sort of the old-fashioned dinosaurs that some kids had in the 80s.
Yeah.
The wooden dinosaurs. This is very much the same kind of thing, right? You see 12, 13, 14, 15, 16, 17 slices of the buck from the front of the B pillar all the way back to the rear of the car. So we see actually also what we've designed, the bright work for the side windows. This also, of course, was designed in CAD. It had to fit to the car, it had to be produced. And we now show you the buck for the boot, which is a separate buck.
So here we see the tailgate floating with the body, removing those.
And that is it indeed. So you can see
it's really a skin laid over the buck.
Yeah, and this is how it was made. So the buck was a crucial part to measure the metalwork. And it was used in many different ways to make sure it would fit to the car. And we actually have it here, so I'm going to invite you with me to come outside of the studio. That's it. So what we have here, 1, 2, 3, 4, 5, etc., and then the A, B, C, D, etc., etc. The different slices. Here you can see the shape of the rear window that would fit in there. And a little bit lower is the number plate emboss.
And even the feature line would run like this, but that's really difficult to see.
Yeah, the buck is mainly there for the main surfaces to make sure that the craftspeople in the workshop that hand beat the metalwork of Henry II can completely understand the three-dimensionality of the shape we designed. So, thank you again for tuning in, very much appreciated. We hope you enjoyed this episode where Tim and myself have explained a bit about the CAD work of the exterior of Henry II. And we're looking forward to welcoming you for our next video of Into Design. Thank you.